Well friends, in this particular video I am going to explain you the concept of Joule's law of heating. Now earlier in the lesson you people have studied in the heating effect of electric current, you people have studied that electricity as electricity is passed for an interval of time in a metallic conductor, then because of resistance a part of electric current is transformed to heat energy. Okay, so on the basis of that, we have this derivation of Joule's law of heating. Now let's see, suppose we are given a resistance, the value of resistance is R, okay, and a current of value I flows through across this resistance, right? Suppose a potential between a potential in the circuit, potential difference across the circuit is represented by the value V. Now we can write further that energy required, okay, for passage of this current for time t, energy required for time t is given by the formula VIT. Okay, now this energy gets converted into heat energy. Remember this energy is converted to heat energy. Alright, so replacing this equation that can be written as the heat energy is represented by the value H. H is equal to VIT. Now according to Ohm's law, by Ohm's law, we know that V is the equivalent to IR. V is equal to IR, or V is directly proportional to IR. So replacing this value of V in this equation, we get H is equal to IR multiplied by I into T. So lastly, taking the value of I together, you get H is equal to I square RT. So this equation that you see, it was accepted by Joule's. Okay, and according to this, what do we find? We find that the heat generated is equivalent to the square of the current flowing through it. It means the more amount of current that flows, that will increase the amount of heat. Second, the heat energy generated is directly proportional to resistance. So as the resistance increases, the heat generated also increases. And third, heat energy is directly proportional to time. If the current is flowing through the conductor for a very long time, then obviously the amount of heat generated will increase. Okay, for the same for which the current flows, the amount of time t for which the current flows, we see this. Now, where is this phenomena used? Now, this phenomena used in appliances like heater, okay, which have conducting wires of high resistances. Second, it is also used in electric bulbs. Now, electric bulb has a tungsten filament. Okay, it is coiled. So that tungsten filament, okay, it transforms large amount of electric current into form of heat by providing a lot of resistance. And also this particular phenomena, it utilized to make fuses which allow specific currents like 1 ampere, 5 amperes, 10 amperes to pass through them. So if the current exceeds or is more than the limit of that particular metal conductor in fuse, metallic wire in a fuse, then obviously the fuse breaks because it has a low melting point. Well, this marks the end of Joule's law of heating.